Good morning. Today we will see one problem where we are going to study the application of the superposition theorem. So here we are asked to analyze the given network by using the superposition theorem. In the given network, we have the two sources of EMFs, E1 and E2, and the three resistors R1, R2 and R3 connected. And you are asked to find out the current flowing through the resistor R3 when we have both the sources of EMFs connected in the circuit. So let us see the application of this superposition theorem, how to apply this superposition theorem in order to analyze the given network. So this is how we can proceed. In the first step, what we need to do is, as per superposition theorem, we have said that in this linear bilateral network, according to the superposition theorem, in a linear bilateral network, if there are number of voltage or current sources acting simultaneously, then the current through or the voltage across a certain element is equal to the algebraic sum of the currents or the voltages due to produced independently by each source. So the algebraic sum of these currents or the voltages due to individual sources gives the total current in the presence of all the sources in the given network. So here what we need to do is, we have to find out the current flowing through this resistance R3, that is 3 ohm resistor, individually due to the sources E1 and E2, and then the sum, algebraic sum of these currents due to the individual sources will give us the total current flowing through this resistance R3 in the presence of both the sources of EMFs, that is E1 and E2. So this process consists of the two steps. So the first step, we have to find out the effect due to E1. Current through R3 due to E1. So when we want to obtain the effect of E1, we have to kill the second source E2 for its EMF, retaining its internal resistance in the circuit. So in the given network, the source E2 does not have any internal resistance. So we can consider as if the internal resistance of the source E2 is 0. So by removing the source of EMF E2 for its EMF in the circuit, the network will reduce to the form, say this is R1, this is R2, this is R3. The second source is to be killed for its EMF, retaining its internal resistance in the circuit. So this is V1, R1, R2 and R3. Now let us consider I1 is the current flowing through this resistance R3 only due to the source E1. Let us consider I1 is the current flowing through this resistance R3 only in the presence of E1 when E2 is killed for its EMF. So in order to find the value of I1, let us first calculate the total current I sent by the source E1. To find the total current I sent by the source E1, we must first know the total resistance of this circuit. So, total resistance of circuit is equal to R1 plus R2 parallel R. Here what we observe is that the parallel combination of R2 and R3 is connected in series with the resistance R1. So that is the total resistance of the circuit. So this total resistance of the circuit works out to be R1 is 4 ohm and the equivalent resistance of the parallel combination of R2 and R3 is 5 into 3 divided by 5 plus 3. So this works out to be equal to 4 plus 15 upon 8. So 4 plus 15 by 8 works out to be 5.87 ohm. The total resistance of the circuit works out to be equal to 5.87 ohm. So knowing the total resistance of the circuit, now we can find out the total current I sent by the source E1 in the circuit, and this current I will be equal to E1 upon the total resistance of the circuit, say is R. So this is R. So this is equal to E1 is 12 volt divided by total resistance of the circuit is 5.87 ohm, and this total current I works out to be equal to 2.04 amps. The total current sent by the source E1 works out to be equal to 2.04 ampere. Now, when this total current I arrives at this junction, certain part of the current flows through the resistance R2 and the part I1 flow through R3. So, the fraction of the current flowing through the resistance R3 is obtained by using the current division formula. We have seen the current division formula is given by I1 is equal to R2 upon R2 plus R3 into the total current I sent by the source. R2 here is 5 ohm divided by 5 plus 3 into the total current sent by the source is 2.04 ampere. So I1, if we solve this, this is 5 upon 8 into 2.04. So this works out to be equal to 1.27 ampere. So this is the current flowing through the resistance R3 only because of E1, that is in the absence of E2. So this is the current I1 flowing through the resistance R3 due to E1, and this is 1.27 ampere. Now we shall find out the effect due to the source E2. The second step is the current flowing through the resistance R3 due to E2. When we want to find out the current flowing through this resistance R3 due to E2, we have to kill the first source of EMF E1 for its EMF, retaining its internal resistance in the circuit. So in the given network, no internal resistance is mentioned here. So we can consider as if its internal resistance is 0. So by short circuiting the source even for its EMF, the network will reduce to the form like this. This is E2, R1, R2 and R2. So when we have this source E2 connected in the circuit and E1 is killed for its EMF, then this source E2 will send a certain current I to flow through the circuit, or considered to be I prime. So when this current I prime arrives at the junction, a certain part of the current will flow through this resistance R3 and say it is equal to I2, and the remaining current will flow through R1, that is I prime minus I2. So we are interested to obtain the current I2 flowing through this resistance R3 only due to the source E2. So to find out the current flowing through this resistance R3 only because of E2, we must first know what is the total current I prime sent by the source in the circuit. And to find out the total current I prime sent by the source E2 in the circuit, we must first know the total resistance of the circuit. Say R prime is equal to, here it is R2 plus R1 parallel R. Here what we observe is that the parallel combination of R1 and R3 is connected in series with the resistance R2. So substituting the values of R1, R2 and R3 here, we get R prime to be equal to R2 is 5 ohm plus R1 parallel R3 is 4 into 3 divided by 4 plus 3. So this is equal to 5 plus 12 by 7. And this works out to be equal to 5 plus 12 by 7. It works out to be equal to 6.71 ohm. The total resistance R prime of the network works out to be equal to 6.71 ohm. So knowing this total resistance of the circuit, now we can find the current I prime. The total current I prime sent by the source E2 in the absence of E1 will be equal to E2 divided by R prime, and this is equal to E2 is 6 volt divided by R prime is 6.71 ohm. So this works out to be equal to 0.89 ampere. The current sent by the source E2 in the circuit works out to be equal to 0.89 ampere. Now, if this is the total current I prime sent by the source E2 in the circuit, how much fraction flows through this resistance R3 is obtained by using again the current division formula. So using the current division formula, the current flowing through this resistance R3 will be given by R1 upon R1 plus R3 into I. So substituting the values of R1, R3 and I prime here, R1 is 4 ohm divided by 4 plus 3 into 0.29. So if you solve this, it works out to be 0.508. The current I2 sent by the source E2 to this resistance R3 works out to be equal to 0.508 ampere. So, in the absence of E2, the current flowing through R3 is 1.27 ampere, and in the absence of E1, the current sent by the source E2 through this resistance R3 is I2 equal to 0.508 ampere. And one more thing, it is observed that both the sources E1 and E2 send the currents I1 and I2 in the same direction through this resistance R3. Therefore, the total current flowing through this resistance R3 will be equal to, therefore, total current to R3, that is 3 ohm resistor, in the presence of both the sources E1 and E2 is I1 plus I2, and this is equal to 1.27 ampere plus 0.508 ampere. So it works out to be equal to 1.778 ampere. The total current sent by the sources E1 and E2 through the resistor R3 works out to be equal to 1.778 ampere. So that is how we can apply the superposition theorem in order to analyze the given network. That is how we can apply the superposition theorem in order to analyze the given network. So that is the application of the superposition theorem in order to analyze the given network. So next part we want to study is the maximum power transfer theorem, that will continue in the next video. Thank you.